Okay, we're in section 41. The structure of the document's really, each section is really basically the same structure. There'll be contents, there'll be examples, there'll be exercises. My name is Ron Bannon. This is a draft version of Webster Wells' Advanced Course in Algebra. That dates back to 1904. This PDF is being prepared for the Prison Mathematics Project. At some point in the future, it will be published. If you're interested in obtaining more information about the document, I would recommend you reach out to me. My name is Ron Bannon. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right? Now, I got to be honest with you, language changes, but the meaning of the words certainly evolves as well. These words that Wells is using are really no longer used, at least not to my knowledge. They're no longer being used. But the methods still are, right? They have different words for them, right? Our recommendation is to read through it, including if you're confused by what you've read, right? This is a tough section, though. There's no doubt about it. So I would say read through it. It's a tough section, all right? There's also some subtleties that he doesn't mention, but read through the section, all right? I think I still have to update the section, but read through it. So my claim over here is I would like to understand what they want me to do. And the first thing I would recommend you do is that radicals as written, and I want to mention what I mean by a radical. This is a radical. It's a fifth root of something that's being cubed. I would like to know really what a radical means to me. And I'm going to write this down for you. There's the nth root. This is how we read that, the nth root of some number A. I'm going to say this really means that A is being raised to the power 1 over n, which for a lot of students still doesn't make any sense, but I'll tell you what they want. They want to know, can A be broken into n equal factors? And if it can, they want 1. Now let's look at this one over here. And I got to be honest with you, looking at this thing over here, if I looked at it, let me just put this down now. If I put a square here, I'm going to say it means this. Let me tell you what that means. They want 2 of the n equal factors. Well, let's look at this. What do you get? I'll write this down for you. I'll be very careful. They want 3 of the 5 equal factors of this guy here. Let's see if you can write down 5 factors for 32. I think it's pretty easy. Like if you did 32, what would you get? 2, 2, 2, 2, 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. If you looked at A10, though, and someone said, what are the 5 factors there? It would be A squared, A squared, A squared, A squared, A squared. So let me write this down. You're going to get 2A squared, 2A squared, 2A squared, 2A squared, 2A squared. What do they want? They want 3 of the 5 equal factors. 1, 2, 3. Let's write that down for you. What would you get? 2A squared, and there's 3 of them. What does this give you? Well, 2 cubed is 8, because 2 times 2 is 4, times 2 is 8. And A squared to the third power is A6. Let's go to the next one. A little more complicated. What do they want? They want 3 equal factors. How do I know that? It's a cube root. They want 1 of those 3 equal factors. Well, let's take a look at it. I certainly know it's a negative number, so I'm going to say minus 3, minus 3, minus 3. Now, why is that? That would give you minus 27. And then the A would be A. How about B6? B squared, B squared, B squared. I realize some students say, do I need to write that down? No, but you need to see that. How about 64 on the bottom? 4, 4, 4. Again, 4 times 4 times 4 is 64. You got C9, which is C cubed, C cubed, C cubed. What do they want? They want 1 of those 3 equal factors. What would you get? Minus 3A, B, squared over 4c cubed. Put a box in that, look at the answer, make sure you're staring at the same answer. All right? Let's go to number 3. There is no number 3. So someone says, what do you do now? Well, Wells is of the opinion you could probably figure the rest out. All right? So maybe not. I don't know. Maybe not. So here's the deal. Exercise. What's the exercise going to be? Well, stuff that we've seen before, seen before. Very similar to previous problems. Seen before. Here comes an example that I forgot to put an example in there for you, but I hope you realize what we're looking for. This is a square root problem, and it's not easy. We're looking for 2 equal factors. 2 equal factors. Someone says really tough to do. You know what? It's not that tough to do. And what I do is I try to help you out with that, what the equal factors are. It's not easy, though. I know it's not easy. I put a lot of work down here for you. So really what I'm saying over here is that I put a lot of work down for you. And the deal about this one over here is that if you thought about it and give it some, again, I know it's a lot of thinking, I want to point out the factorizations are difficult. There's no doubt about it. I want to claim, though, something that Wells does is sort of aggravating. He doesn't consider the cases where you could get this. And he does consider it, but he kind of blows over it a little bit. And I got to be honest with you, it's plus or minus. And the reason for that is it's a square root problem, and even roots cause much bigger problems. This is going to require thinking on your end. You're going to have to think about this. Part of thinking is also reading what Wells says about it. But thinking about that's really important. Again, looking at number 8, you're looking for the 2 equal factors. And again, my intent here is, I'm not going to say it's easy, but you got to factor that guy. And again, there's 2 equal factors over there. The equal factors go 4x minus 3y minus 5z. Again, plus or minus. Again, square roots are more difficult. Even roots in general are more difficult. So, likewise, they got these polynomial things, and you're basically just factoring them. That's all you're doing. You're looking for equal factors. It's not easy, though. I know that. Factoring can be quite aggravating. But we do put work down, and we do put answers for you. All right? A lot of questions, though. A lot of work goes down there for you. Make sure you're paying attention to that. A lot of work goes down in answers. Now, these over here, I got to be honest with you. Wells, it comes from a period of time where calculators were, when I say calculators, I really should say digital calculators, but believe it or not, there were people back then that could actually look at this problem over here and put down an arbitrary precision answer to it by just looking at it. And it's really remarkable that some people could do that. I'm not of that capability, by the way. So I'm going to say over here is you really probably should learn how to use a calculator to do it. But I'll be honest with you, Wells spends a lot of time on being able to do that. What is he looking for? 1 of 2 equal factors, right? That's all he's looking for, the factorization of 99,729.64. It's not easy, by the way, all right? But anyway, we put answers down here for you. I realize a lot of students are going to look at what Wells does and say, oh my God, I was used to calculate, it's so much work. It is a lot of work. What Wells, the period of time where Wells was, he was a lot of work in doing these problems that way. This was not pushing a button on a calculator. But my claim over here, if you took this on a calculator, you're going to get really simple answers really quick. Make sure you know about that, all right? Again, this one's more difficult. It's a cube root problem. You're looking for 3 equal factors. It would be unlikely if you couldn't find 3 equal factors. I go through the work. It's not easy. I know that. Factoring, generally speaking, is not easy. All right? This one over here, you're still looking for 3 equal factors. What do we do for you? We give you the 3 equal factors for you. We actually factor it out for you. All right? Cube root 3 equal factors. This one, it's numerical. Again, what Wells does, what I'm doing, different. Use a calculator. I do mean that. All right? Use a calculator. I mean that. Calculator, calculator. This one over here, more difficult. It's 4 equal factors, and you want one of those 4 equal factors. But anyway, it's not easy. I do talk about how to do it. Again, I don't write a lot of work down it, but probably enough to get you moving on it. All right? This one's the 6th root of this thing over here. Oh, wow, look how long that is. 6 equal factors, right? 6 equal factors. Again, it's not easy, right? Fifth root, we're looking for 5 equal factors of this guy over here. And that's a good tip-off, by the way, 5 equal factors. This one over here, I do recommend using a calculator. I do not recommend doing what Wells does. Again, I recommend using a calculator. I do not recommend what Wells does, calculator. This one over here, I got to be honest with you, there's a footnote over here. And by the footnote over here, it's not in the original problem set. It's a problem that I add on. And I do this sometimes. I'll add on something. I might change the wording of something. I might give you a footnote, whatever. But the document that I'm preparing is not the same as Wells' document. Right? It's based on Wells' document, though. And I talked through that. Again, it's a lot of work, though. I know it's a lot of work. What are you going to be doing? You're eventually going to get to this thing over here. And realize that computers really are quite good at this. What's SAGE? It's a computer algebra system. We abbreviate that with CAS, C-A-S. We actually say CAS. It's free. Go here. When I say it's free, open source software. You can download the software or use the interactive web-based application. And again, we actually go through a problem that's somewhere in the notes, and you're going to be shocked how quickly SAGE can actually factor that polynomial. It's remarkable it can do that. What's remarkable is the people coding this actually are quite good at algebra, and that's why it can be coded. And this coding really is taking place over the decades. All right? Now remember, if you find errors in my notes, I'm not saying you're not, please reach out to me. What's my name? Bannon. What's my email address? Bannon. B as in boy, @ NNON.US. What am I looking forward to hearing? That you found an error. And I'll try to correct it if you do. All right? I'll try to correct. All right? That's about it. Thank you for paying attention.